Guys, welcome to my channel. This is Sathom. I've been diving into using Berkeley CS61A course. Today, I want to talk about one particular function in a project that gave me a surprisingly hard time, even though the logic seems so simple at first. Let's take a look at the Hog project. So basically, we have this project called the Game of Hog. In this project, we will develop a simulator and multiple strategies for the dice game Hog, and I will need to use control statements and higher order functions together, as we learned before. Firstly, it gave us some roles. For example, source set. If any of the dice outcome is 1, the current player's score for the turn is 1, regardless of other values rolled, and some other examples. So what we're going to talk about today is the problem 9. All right, let's take a look at the problem. We have to implement max scoring non-rows function, which runs an experiment using a die with a fixed number of sides to determine the number of rows that gives the maximum average score for the turn. And our implementation should use the function make average and roll dice, which has already been implemented before. So what does this function do? To put it simply, you try rolling different numbers of dice from 1 to 10 and figure out which number gives you the highest average score. You simulate each case by calling a function called makeAverage, which basically runs the simulation many times, like 1,000 rows, and gives you the average score. Then you just compare those averages and return the best number of rows. It's easy, right? I thought so too. Firstly, let's take a look at the two function that has been implemented before. The first one is roll dice. So this is a function simulating rolling the dice exactly number rows times. Return the sum of the outcomes unless any of the outcome is 1, because in that case, the return value is going to be 1. Then is the make average the function. So this is a function takes in two arguments, which the first one is a function and the other one is a variable. So this is obviously a higher order function. It returns a function that returns the average value of original function called times. Okay. So then let's take a look at the function that we're gonna write. So I'll show you the code that I wrote initially. We have this variable called rows number and results. Okay, so here's the code that I wrote initially. It looks okay, right? Let's taste our code. Sorry. Yeah, let's test our code used in the OK system. Oops, we got an error. So in this test, the expected value is 10, while we got 7 from our function rows. Before we talk about our code, let's take a look at the test itself. So we have this dice test, this make test dice function. What this does is for the first 55 dice rows, it always returns 2. After that, it alternates between 1 and 2. And in the rules of Hog, rolling 1 causes a source set, which means your score for that turn is just 1. Yeah, this is the first rule. So, if you roll too many dice too early, you're wasting those precious twos and polluting your results. Then I find the problem of my code. I was calling average dice twice for each value of rows number, and each call burns through dozens of dice rows. I didn't realize I was running out of the good dice before I even reached row count 10. So that's basically the problem is. Then let's talk about the fix. Catch the result. The fix is quite obvious. We just have to call average dice just once. And how do we do this? Yeah, save it in a variable and reuse it. Okay, let's rewrite our function. Like I said before, we have to use a new variable. Let's just call it current dice. Now, since we have this variable called current dice, which was assigned by the value of average dice function, now we can replace all the average dice with current dice. Okay. Let's test our function again. All right, we got 10 test cases passed, no case failed. That means our function is totally right. So this tiny change made all the difference. Now I only call the simulation once per test case, and I preserve the limited number of good dice values. Okay. So that's what I want to share with you guys. What looked like a math problem was actually a resource management problem. I learned a few key things here. The first is never assume a function is cheap, because some may have hidden side effects or limited states. The second thing is read test cases carefully, especially in CS61A. The tests are smart and intentional. All right, let's take a look at the test we had. And now you can see the hints right there. Test that you're not rolling the dice more than necessary. At the first attempt, I didn't realize that. I didn't understand what that mean, but now I know. The third thing is think before you recall a function that involves randomness or internal state. So this wasn't about knowing Python better. It was about thinking like a computer science, and that's why I want to share this problem that I met with you. So if you are struggling with this problem, here's my advice. Pretend that your dice are gold, use them carefully. And if a function simulates randomness, treat it like a limited resource. Last but not least, always catch your values from expensive or stateful cores. Okay, that's basically all for my video today. If you found this helpful, drop a like, or better yet, let me know if in the comments if you also got wrecked by this problem. And if you are also working through CS60A or other Python projects, I'll be sharing more breakdowns soon. Hit the subscribe and we will debug the pain together. Thanks for watching.